Hi everyone, today I'm going to explain about question 1, where there's a correction in the question in which 24 periods is changed to 18 periods. So in the first paragraph, the question told us that the current price is 45, the volatility is 30%, which is 0.3. The stock does not pay dividends, so delta is equals to 0. And also the stock price follows the binomial models with 18 periods, each of length 1 month. The continuously compounded risk-free interest rate R is 6% per annum, so 0.06. So we put all the information given in this table, and then we calculate H, which is equals to T over N, U, which is equals to exponential of R minus delta multiplied by H plus sigma square root of H. And then for D, it's similar with the difference being minus in between the terms. For P, it's calculated by using this formula, R minus delta multiplied by H minus D divided by U minus D. And for Q, it's just 1 minus P star. So because the stock price follows a binomial model, we create a table with the period and time, where at period 18, the total time is 1. And then we produce a table with the stock price, with the initial stock price being 45, and then applying this formula involving U and D to calculate the stock price for each period according to different paths. So we will obtain the lowest stock price as 10.36 and the highest stock price as 234.04. Then to confirm that the calculation and formula in the table is correct, we can illustrate it with a binomial tree, where the binomial tree also illustrates the same highest and lowest stock price, which tells us that the stock price calculated is correct. Next, there are two sub-questions for this question, where the first one is an 18-month Asian average strike put option on stock. Vodafone stock uses a geometric average based on the stock price at the end of each month. The price for this Asian option is PG. And the next one is an 18-month Asian average price call option on the stock uses an arithmetic average based on the stock price at the end of each month with strike 44. The price for this Asian option is CA. So we need to find PG and CA. To calculate the geometric average and arithmetic average for each path in the binomial model, we need to use Python to do the codings to calculate the arithmetic and geometric prices. The code for geometric average is pasted here, where the first part includes the formulas that we have calculated using Excel just now, and we apply this whole series of codes to finally calculate the geometric average, which is the multiplication of each stock price to the power of 1 over the number of values in that path. And then we extract the output into a separate Excel file before copy pasting it into a new sheet here for easier reference. So we calculated the geometric average values in column T. Then we calculate these two columns, number of ups and number of downs, using these formulas to identify each geometric average price and its path. Then we apply this formula to match the stock price that we have obtained from the binomial tree to the number of downs in each path, so that we can match the stock price to each geometric average path. We do this for all the rows in column W, and we will match all the prices that we have calculated in this stock price table into this column. Then we apply this formula to calculate the payoff. For the first sub-question, it's Asian average strike put option. So the payoff is geometric average minus the stock price. Geometric average acts as the K, which is calculated in the output from Python. So we apply this formula where there would be a payoff value larger than 0 only when the geometric average is larger than the stock price. If the geometric average value is less than the stock price, then the payoff would be 0. Next, for probability, we calculate it by using the probability of ups that we have calculated in the previous Excel sheet to the power of the number of ups multiplied by the probability of downs to the power of number of downs in each path to obtain the probability. Then to calculate the payoff multiplied by probability, we multiply column X and Y to obtain the payoff times probability of each row. For sum, we add up all the rows in column Z so that we can link it to our original main Excel sheet where the sum is then copy pasted link over here, and then to calculate PG we multiply the sum by exponential of negative RT, which is C6 over 12. And then for the second sub-question, it is Asian average price called with a strike price of 44 using an arithmetic average. So for arithmetic average, the output from Python is copy-pasted in a new Excel sheet. The codes are here. It's the similar codes as geometric average with slight changes in this small part where the formula is changed. Instead of to the power of 1 over the number of values, it's instead added up together divided by the number of values, which is the average. And also sum plus equals to table ij instead of multiply equals to. And this part, just now it was multiply equals to 1, but now we start with 0. These are the codes for arithmetic average, and we would obtain this output with the arithmetic average at period 18 calculated in column T. Then for the payoff of an Asian average price call option, we calculate it by using arithmetic average minus the strike price, which is 44 as mentioned in the question. So similar to the first sub-question, a payoff greater than 0 would only happen if the arithmetic average is larger than the strike price of 44. If the arithmetic average is lower than the strike price of 44, then there would be a payoff of 0. And the probability uses the same formula as before, probability of ups to the power of number of up multiplied by probability of down to the power of number of downs in that particular path. Then payoff multiplied by probability, this column is to multiply column U and column V. Lastly, for the sum, we add up all the rows in column W to link it to this Excel sheet that we had earlier. So to calculate CA, it's similar. We multiply it by the exponential of negative RT. So 18 over 12. Finally, the question asks for PG minus CA. So PG minus CA is C15 minus C19, which is negative 2.8303. So By then, we have completed all the questions all the sub questions in this question. That's all for today. Thank you.